Determine the horizontal and vertical components force at pins A and C of the two-member frame. Repeat again. We'll determine the horizontal and vertical components of the reaction forces at pins A and C for a two-member frame. The top member, AB, is 3 meters long and carries a uniform load of 200 newtons per meter. We will replace the distributed load with a single equivalent point load. Identify a two-force member. Write equilibrium equations and solve for the reactions at A and C. Let's draw the frame and the loading. Pin at A, on the left, horizontal member to B, and a slanted member from B down to C. Place the uniform load on AB as a row of small downward arrows and label 200 newtons per meter. Now replace it conceptually by a single equivalent point load at the midspan of AB because the load is uniform. Note the geometry for the slanted member BC, 3 meters horizontal and 3 meters vertical, which implies a 45-degree line. Member BC is connected by pins at both ends and has no other external forces acting directly on it, so it is a two-force member. Its force on joint B must act along the line through B and C, which makes a 45-degree angle with the horizontal. Now, take moments about A on member A. B to eliminate the unknown reactions at A, counterclockwise positive. The vertical component of the BC force times 3 meters must balance the equivalent load of 600 newtons acting at 1.5 meters. So we write FBC times cosine 45 degrees times 3 equals 600 times 1.5. From this, the vertical component at B is 300 newtons upward, and the magnitude FBC is 300 divided by cosine 45 degrees, which is approximately 424.26 newtons. Next, use vertical force equilibrium on member AB. Sum of forces in the vertical direction equals 0. AY plus FBC cosine 45 minus 600 equals 0. Therefore, AY equals 600 minus 300, which is 300 newtons upward. Now use horizontal force equilibrium on member AB. Sum of forces in the horizontal direction equals 0, minus AX plus FBC sine 45 equals 0. Therefore, AX equals FBC sine 45, which is 300 newtons to the right. Finally, consider the pin at C. Because BC is a two-force member, the force in it is the same magnitude everywhere acting along the member. Thus, the horizontal and vertical components at C have the same magnitudes as the components at B, namely 300 newtons each. We report magnitudes for CX and CY. Here is the way that we compute the horizontal and vertical components force at pins A and C of the two-member frame. Do you think this videos help you or not? If it is helpful, share this video to your classmates. Don't waste your time. Study, because you still have a chance. Thanks.